Hey, what's going on, guys? This is me, Ivan Yusuf, and welcome to another tutorial using Python and Pygame. Now in this tutorial I decided to create a very simple game, but since yesterday was Halloween I decided to make a Halloween theme. Make it more like Halloweenish in nature. So I decided to create a game called Pico, Fermi, Bagels. And if you have never heard of that game, it is a simple number guessing game. So we have one player, he picks up a random 3-digit number, and the other player needs to guess what is that 3-digit number. And the digits in the secret number, they must be unique. So you cannot have like 121 because 1 is repeated twice, or 442 because we've got 2 4s, or 777 because we have like 3 7s. And every time the person is guessing a number, the person who came up with the secret number, with the secret 3-digit number, gives him like clues. For example, bagel means that none of the digits are correct. Pico means that one of the digits is correct, but it is in the wrong place. And Fermi means that one of the digits is correct, and it is in the correct place. So pretty much you win the game when you have 3 Fermis. That means all of the 3 digits are correct, and they're in the correct place. And there is an online version of that game, here at this address, and I will be these links will be provided in the description of the video. For example, here you can play it with more than 3 digits, but this is really hard. It's not a very easy game. Usually we have like I'm not sure if that was set somewhere here, but I think you have only 10 tries. So in 10 tries you need to guess the secret number. For example, if I place here, so bagels means that none of these numbers are part of the secret number. So 1, 2, and 3. So 4, 5, 6, 6 means I've got 2 picos. So 2 of these numbers are correct, but they're in the wrong place. So let's try 6, 4, 5. So that means that one of the numbers is in the correct position, and the other one is correct, but it's in the wrong position. And pretty much we have 10 tries, or in this case we have 16. Also you might disallow zeros, and you might give more numbers. Anyway, this is the game we'll be doing here with Pygame. And what I decided to do is instead of numbers we'll be using these trick-or-treating costumes or masks. On Halloween, when you're visited by kids that are dressed as certain, in certain costumes. So instead of 10 digits, we have 10 costumes, and you try to guess what is the correct order. So which of these 3 are coming to visit you. So let's say we pick this and this and this, and then we try to guess, and we've got Fermi. That means that one of these is in its correct position and the other ones are not correct. 2, 8, and I actually happen to know that this is in the correct position, so this should be here, and if I guess again, I've got Fermi, so 2 are correct. And actually the first one is not correct. The first one should be the second one. So if I put it here, guess I've got you won, congratulations. Press space to play again. And when you press space, you can start again. Let's see. I've got Fermi, which means that one of these is in the correct position. We're not going to play, but if you run out of tries and you've got 10 tries, you die and try again next Halloween. or you can press space to play again, and the game starts again. So pretty much this is what we'll be doing. And also we have this button for instructions, and when you click it, you get the instructions for the game. You know, the goal is to find which 3 trick-or-treaters are coming. They must be unique, so you cannot have 2 of the same. And here are the rules. Pico, it's correct guess but wrong place. Fermi, correct guess, correct place, and that's what you're trying to get. And Bagels means nothing is correct, and you have 10 tries. So this is the game we'll be building. I think it is pretty fun, so I hope you'll enjoy it. So okay, let's go ahead and get started. So again, these are the rules. I'll be posting these links in the description. And let's start actually with the font. We'll be using this unfinished screen. It is 100% free. So actually, let me prepare the folders. So I have one for fonts, one for images, and I believe that's all. That's all we need. And here we'll be using this one, unfinished screen regular. And we don't need the other ones. Okay, for the pictures, we'll be using this picture. It is from Pygame. And I'll call it Halloween BG because this will be the background picture. Now from this Halloween free icon pack, we'll be using a bunch of images. First of all, I'll be using this ghost image for the win, when we win the game. When we lose, oh, okay, they're right next to each other. We'll be using this tombstone image. Now besides these images, we'll also be using the costume images, and I picked up a couple of these ones like Frankenstein, Dracula, that's Freddy, the Witch, and you can choose whatever you want. There are a bunch of images in here, and I'm not gonna be downloading them. I pre-downloaded them all and placed them in their own separate file called Tricksters. And here I just named them from 1 to 10. So these will be instead of digits. We'll be using pictures instead of digits. So we're trying to guess which of these trick-or-treaters are coming to us this Halloween, and we'll try to guess their correct order also. And all of the images are 128 by 128. So that's pretty much all the resources we need. Now I'm gonna create our main Python file. We'll be writing the logic of the game. and I'll open it in the Mu editor. And this is the old one, so I'll load it in here. No. Oh. Set. Okay, I'll just create here the okay. Let's try to see if this is working. Okay, so we have the main file. We'll be writing the logic for the game, and we'll be needing the Pygame module. So if you're using Mu editor, you can click the settings here, tap third-party packages, and write Pygame, and click OK, and fill down the Pygame module. Okay. So, and when you import Pygame and you run the game, you should see this one, Hello from Pygame Community, which means that Pygame is running and you can use it. Okay, besides the Pygame module, we'll be using also some other modules. So we'll also be using the random module, OS, and I believe that's it. I'll also be using the math module, and I'll explain what they're doing when we get to them. Okay, so we need to create the skeleton of our game, and we need to set up some variables. So we'll start with the width and the height. So here we're setting the screen of the game, so that will take care of creating the game window with the specified dimensions 900 by 600, and this is the caption of the game. So this is what appears up here. Okay, for the frames per second, since we don't have any animation in the game, we'll be just setting it to 10. That means the game will run 10 times per second, which is quite low, but since we don't have any animations, that's okay. And the clock variable will be taking care of making sure that the game runs at 10 frames per second. Besides that, we'll also be using a couple of colors for this game. And in Pygame we set colors using a tuple. So we have 3 values for the red, green and blue. These are the color channels respectively. Okay, now every Pygame needs to have a game loop, and inside of the game loop we need to run the event loop. The event loop will listen for all the events that are happening inside of the game. For example, when you're pressing a key on the keyboard or when you're clicking the mouse. So we need to be listening for these type of events. And the first event we need to be listening is when we are clicking the close button of the program. So each this screen variable will create the game window, and each window will have these three buttons for minimize, maximize, and close. And we need to be listening for the close button. When the user presses the close button, we need to close the program. And this Pygame quit refers to the close button. And we're going to set running equals to false. So when we set running equals to false, the game loop will exit. Now inside of the game loop, we're going to also be updating the display. And we need to call this command so that everything that is happening inside of the game window needs to be updated. For example, when we are bringing images or when we are changing something on the screen, we need to run this command so that these changes will appear on the game window. And last but not least, we need to tick the clock and pass the FPS variable that we created up here. So this clock variable will make sure that this while loop or this game loop is running 10 times per second. So the game will run at the same speed no matter how fast the computer is. And when we exit the while loop by pressing invoking the quit command, when we press the close button, we're gonna quit Pygame. So let's actually try this one. So here's the game window. It's 900 by 600. We have the caption here at the top, and we have this close button. And when I click the close button, the game window closes. So that's what we want. That's what we want to happen. Now, besides that, I also want to make sure that also when I click the escape button, the window will close. So in order to listen for the key press, we need to listen for a key down event. So the key down event, and then we need to listen for the escape key specifically. And again we'll set running equals to false. So if I run this game again, this window appears, and now I'm gonna press the escape button, and the game closes. So here we're listening for the key down event, and each key in Pygame has an alias of sort. So for example, k_escape. We're listening for the escape key. If it's k_, for example, space, we're listening for the space bar, and so forth. So this is pretty much what we want to do here. Now, in here, between the event loop and between the updating of the screen, we need to write the logic of our game. Now, in order to write that logic, I'm not going to be writing it in here. I'll be using object-oriented programming, and I'll create different objects for the things we'll be using. And one of the objects I'll create is the game object. So the game object will take care of all the things that are happening in our program. And it really doesn't matter where you. Oh, you know what, guys? We forgot to initialize. Did we do that? No. Yeah, we need to initialize Pygame. It's just a good practice. So there we have it. It's running again. Yeah, we need to initialize Pygame, and we need to quit Pygame between these two lines. We're writing everything that is happening in the game. So we'll be using a couple of classes to represent, for example, the images and some other things. So we'll start by creating a game class. And like I said, it doesn't matter where you create the classes. I'll be creating them in here. Now the game class, it will have a couple of functions. So of course we need the initialize function first. And for the time being, I'll put pass. We'll be writing some variables in here. But this function will also have two very important functions. One of them will be the update function. I'm sorry. And again, I'll write the definition in a minute. And we also have the draw function. So the draw function will take care of drawing stuff on the screen. Update function will take care of updating stuff on the screen and also listening for events. And pretty much this is the function that we want to be calling inside of our game loop. But of course, before we can call this function, we need to create an instance from the game class. So in here, I'll create game equals game. So this will initialize. This line will call the initialize function of the game class. And in here we'll be writing some of the logic that needs to happen before we start playing the game. And when we initialize the game, here in the game loop, we'll be calling the update function. And the update function will be calling the draw function. And it will be also calling the function that will be processing events that are happening. Now, in order to process these events, I will pass the events, because here we're calling the event loop, and I don't want to create event loop here and then in the update function create another event loop. So I will extract those events here in an event list. And this event list, I will call it here. So in the game loop, I will get the event list of all the events that are happening, and I'll be listening for the quit event and for the escape key when it's pressed. But also inside of the game, I'll be listening for other things. For example, when I'm clicking the mouse or when I'm pressing the spacebar. So I'll be passing this event list also as a parameter to the update function of the game class, of the game object. So this event list, I will pass it also as a parameter here. And I'll be using a function that will be processing these events inside of the game object. So the update function will be taking care of drawing stuff on the screen and processing user input. So of course the user input needs to get the event list. It needs to know which events are happening, and then do something based on the events that are happening. And you'll see that in a minute. So besides the draw function, I also need the user input function, and it will be taking the event list. And let me run this program again. And of course, when we're calling functions, we need to call them with self, because these functions belong to the instance of the class. So nothing is happening, but we know that this thing is working. We just need to write the logic inside of these classes, inside of these methods. So I'm actually going to start with the draw function, and what I want to do first is just show the UI that we need to play the game, and later we'll be adding the logic how to play the game. So first of all, in the init function, I'll be initializing a couple of variables that I'll be using in the draw function, and also some other things. So one of the things we'll be needing is how many tries we have left. And when we start the game, we want to start with 10 tries. And every time we try to guess, we'll be decrementing by 1. So I'm writing this as self tries left because I'll be using it in the draw function and also in the update function. I mean the user input function. Tries left. We also have a Boolean variable called winner, and that will, when we start the game, we don't want to start the game winning. So when we win the game, we'll be using this variable to show the winning screen. Now for the end screen, I mean whether we win or whether we lose, we'll be showing these images, this ghost and tombstone. So I'll be creating these images in here. So when I create the image, I also create a rectangle around the image so that I can better position it. And when I create the rectangle around the image, I will center it in the center of the screen. And we can actually show this thing, even though we're going to be showing it a little bit later. I mean at the end of the game. So using the Blitz command, we can show images on the screen, and the Blitz command accepts 2 parameters. The one is the image, and here's the image that we loaded from the image directory, and then the rectangle, I mean the positioning of the image. So for the positioning, we're using the center of the width and the center of the height, so it will place it right in the middle. And if we run the game, we can see that tombstone right in the center of the image. Now, we don't want to blitz this image right now. We want to blitz it in the end when we lose the game. I mean, if we lose the game. But let me just add also the ghost image. The ghost image will be used when we win the game, and the tombstone image, so image when we lose the game, image when we win the game. And like I said, we'll be using these images at the end of the screen. I just wanted to load them right now so they don't get in the way later. Now, actually the first thing we want to call here in the draw function is the background image. So just like these images, we need to load them. And I'll call it just BG. Actually, it's a good practice when we are loading the images to call this function convert alpha. It will make loading the images faster, so I'll have it here and also here. It's just a good practice. And I'll use the top left coordinate 0, 0. So top left says so this image, top left is over here. So take the position of the image, take the top left corner, which is 0, 0. And we'll be using this one to position it on the screen because we want to take up the whole screen. Okay, and let's actually blitz this thing here. Now it's a good thing to fill the screen with black or whatever color you like, and then blitz the image. So for example, if I use orange, you will see it will fill the wait. Oh, it's a JPG file, okay. So we have orange. We use this command to fill the screen with a color, and then we blitz the image. So in this case, we'll be blitzing the background image. And the second parameter is the position of the image. So for the position, as we said, we'll be using the top left coordinate, so 0, 0. Now, this is the top left coordinate of the image, so here. But as you see, that the image is actually bigger than the image is bigger than the dimensions of the window. So one good thing we can do with the image is we can scale it. So and this function, Pygame function, Pygame transform smooth scale, accepts two parameters. One is the image that we want to scale, so in this case self bg, and the other parameter is like the dimensions that we want to give it. and I wanna, for the dimensions, I wanna pass the dimensions of the these dimensions of the window. So window width and window height. And if I run the game, we see that the image is scaled, so it fits nicely in the inside of the window here. Now, for the next part, here in the draw function, we'll be actually creating a couple of fonts, because we need to also, you know, show the text on the screen. And I need you guys to bear with me, because we need to write a little bit of text right now. So here in the beginning of the draw function, we'll define the fonts that we'll be using. So we'll have a title font, which will be for the title. And from the fonts directory, we'll be loading this font. And the second parameter is how big the font is. In this case, 84 pixels. Besides that, we'll have a content font. And again, we'll be using this font, but it will be like 60 pixels, so it will be smaller than the title font. And we'll also be using a text font. And for the text font, we'll be using a system font. And I'll be using Arial 20. And if you do not have Arial, you can use whatever font you like. You can place here none, and it will still work. None will take the default font on your system, but I'll be using Arial. And we'll be using this thing when we give the clues, because the interface will get a little bit cluttered with all these fonts. Okay, so these are the fonts we'll be using, and here we'll define the texts that we'll be using, and here will be the GUI. Actually, the UI. The user interface will be showing the user interface. We'll be blitzing stuff on the screen. So for the texts, we'll have text with a title, and it will use the title font. And the title font will say the name of the game. So the second parameter is true, which is anti-aliasing, which is almost always true. And for the color, I'll use crimson. Now for this text, I also need a rectangle around it, so I can position it. And I'll be using top left for this one. Now next to the title text, I'll be using also I want to place this Halloween edition next to it. And I'll call it subtext. Actually, I'll be using the content font here. So it's smaller. It's a smaller font size. And I'll be using this pumpkin color, this orange color. Okay, let's blitz that thing to the screen. So here's the title text, and it's 130 from the left and 10 from the top. And for the Halloween edition, it's 500 from the left and 20 from the top. Okay, so this is our title. Now underneath the title, I want to show the instruction, the button for the instructions. Now for the instructions, I want to make sure there's like space between the letters, so I'll write them in this way. I use the center position. So here are the instructions, and actually I didn't want it to be that big. I'll use the text font for this one. So I'm using the text font, which is 20 Arial, and there it is. Now I want to make this a button, so I want to give it a background. And I can make the background in here in the draw method, but also I need to detect when I'm clicking the draw method, when I'm clicking the instruction button. So I'm gonna define it in here. And I know, guys, that you know, it's better to create a separate class for the buttons, but since we have only 2 buttons, I'll just do them inline inside of the game class. But in later tutorials, I'll be showing you how to use how to create UI element as separate classes. It will make programming much easier. But for this occasion, I'll just make them in here. Now, for the background, I want to create a surface and then fill this surface with the color. So Pygame has this function, surface. And the surface accepts a tuple of dimensions, so the width and the height, and I use 200 by 44. So the bottom, I will fill it. So this surface is just like the screen surface. I can fill it just like we fill the screen. The screen is also a surface. We fill it with orange. We can fill it with whatever color we want here. I'll fill it with crimson, and of course we need to give it a position. Okay, so let's show it here. So we're building this surface, which is filled with crimson, and the position. So when I run it, we see that the surface appears, but the text disappeared. And the reason why the text disappeared is because we put the surface after the text, and when Pygame runs the code, it executes these in order. So it showed the text, but then it showed the surface, the crimson surface on top of the text. So all I have to do is cut this one and put it before the text. So if I run it, we get this instructions button, and right now it doesn't do anything because we haven't written the logic for pressing the button. Okay, but let's actually add the other button. So here for the buttons, we'll add the button for when the user tries to click, tries to guess the tricksters that he needs to guess. So let's see, we'll call it a guess button. And just like the previous button, it will be a surface. So this will be a little bit smaller. And we'll fill it with orange. Yeah, we'll fill it with orange. So the guess button will be again horizontally centered, and vertically it will be also centered, but we'll add 160 pixels. So it will be pretty much in the center and then 160 down. And here for the instruction button, okay, never mind. So let's actually show this button again. Okay, we also need to, besides the surface, we also need to add the text for this button. And again, I'll be using this trick to add a space between the letters, otherwise they'll be very close to each other, kind of hard to read when we're using this system font. And the reason I'm not using this other font that we imported is because it's when it gets smaller in size, it looks really ugly. And you guys can experiment with your own fonts. And again at 160, just like the surface. So I will place the text after the surface. So first I place the surface and then the text. So there we have the two buttons, and again currently they do nothing because there is no logic behind them. We're not listening for events when we click these surfaces. So actually the next thing I want to do is actually add the this instructions button. When I click it, I want to pop up like a panel with instructions for the game. So here will be instruction panel. Now, in order to show the instruction panel, I will set a Boolean variable that will tell me whether I need to show the instruction panel or not. And in the beginning it will be false. So when this thing is true, the draw method will show the panel. And here I need to create for the panel will be again a surface, and on that surface we'll have text, just like the buttons. And it will be 600 by 200. And we'll fill it with black. And I'll use the mid top. So from the top, I'll take the middle of the top and place it horizontally in the center. Plus 160. So when we show this instruction panel, I want it to appear on top of the instruction button. Okay, let me just blitz it to the screen. Wait. Oh, okay, it appears. Huh. It should be appearing on top. In the top. So. Oh, sorry guys. So from the top it will be, let me see, $94 from the top. And there it is. This is the panel that will hold the instructions. And let me just show the instructions here, and then we'll write the logic for when we're clicking the button. Now, in order to print the instructions, we are going to do something just to speed things up, because the instruction panel will have around 5 or 6 lines of code, and for each line I need to write the text, the position, and then blitz it on the screen. And that's kind of a lot of work. So in here, in the text, I'll create lines and each line will have a text and a color. Okay, and then I need to make the same thing for the next line. Okay. Okay, so the second line, so these are the goals, the instructions for the game. Okay, so instead for each one of them to write, a separate text variable and rect variable, we just place them, we make a array, a list of dictionary values for the text and the color. And then we need to print them after we build the instruction panel, the instruction surface, because they need to appear on top of this surface. So we're gonna write a a for loop. And for this we will use the text font, which is the system font, the Arial 20. So we'll use the text. The second parameter is anti-aliasing true, and the color. And we're gonna blit these lines not on the screen surface, but we'll blit them on the instruction surface. So the instruction surface is that black rectangle, that panel, and on top of it we'll be placing these instructions. Okay, now, so for each line we're actually gonna be using the index variable here. So each line will be 10 pixels from the left, and from the top it will be index times 30 plus 10. So the first one will be 0, so 0 times 30 is 0, it will be 10 pixels from the top. The second will be 1 times 30 is 30, 30 plus 10 is 40, so 40 pixels from the top of the instruction surface. Okay, and let's try it out now. Okay, we need another closing bracket here. And there we have it. All these lines. So this one, the first line is 10 pixels from the top. This is 40 pixels from the top. This is, I think, 90 pixels from the top. So this thing is the left value and this is the top value. So that's why we need the index variable, so that we can, for each line, we can add times 30 plus 10. And there we have them. Now, of course, when we start the game, we don't want this thing to appear. We need to add the logic, but actually first, before we add the logic, I want to add the close button here. And for the close button, we're going to be using just a circle. We'll draw a circle, and inside of the circle we'll put an X, and then we'll be listening also for this event. So when I click this X button, I'm going to close this panel. So after we print the lines here, we'll call the circle method, and the circle method accepts the surface where we want to print it. In this case, we want to print it on the instructions surface. We'll be using the red color, which we don't have. By the way, in Pygame you can also write red. So if you write simple colors like that, you can just pass them as strings. It accepts red, green, etc. But I'll use the color that I defined. And then we also need to pass the where we want to place this this circle. So I want 500 pixels from the left and 20 pixels from the top, and these dimensions are relative to this surface, to the instruction surface. They're not relative to the screen surface. We are writing on the instruction surface, not on the screen surface. And then we have for the radius 10, and for the outline will be 2. And let's see how that will look. Okay, that's That's not where it should be, so 580 from the left, and there we have it in the in this corner. We placed it in this corner. So besides that, I also want to add an X, and I'll just call it close. So it'll be just a text font. And then we want to blitz it on the instructions surface. So there we have it. We have this button. Again, we're not listening for when we're clicking that button, but we're going to be adding it in a minute. But first of all, we want to actually hide this this panel and only show it when we click the instructions button. So here in the initializing of the game object, we have this self-show instructions, which is equal to false. So we want to show the panel and the instructions on the panel only when this is equal to true. So here, when we're drawing the instructions, I'll say if self-show instructions. So if this is true, I mean show it. So right now, if I run it, it doesn't show. So when I click the instructions button, I'm gonna set show instructions equals to true. So that means that here in the user input, I'm passing the event list. So these are all events that are happening. And here I need to start writing the logic for showing the instructions. And in order to write the logic, I of course need to iterate of all this list of events. And in this case, I need to be listening for a mouse click event. So if I click the mouse click event, I need something to happen. So let me just right click, and if I run this and start clicking anywhere on the screen, you see I get this click. I can click anywhere. And one thing I want to add here is I want to listen only for the left click event. So if I click with the right click or the mouse, I don't want to catch these events, only the left mouse events. So event button equals to 1 equals to 1. This is the left mouse button. If it's 2, this is the middle mouse button or the mouse wheel, and 3 is the right mouse button. I want to listen only for the left mouse button. So only if this thing is being clicked, I want to do something. Now, the first thing I want to do is I want to catch the position, the x and y coordinate of the place where the mouse has been clicked. So I will catch this in mouse x. So this will tell me the coordinates where I clicked on the screen. So if I trim them, have a look here. For example, if I click here on the top left, it will be 2, 3. If I move the x coordinate over here, this will get bigger, but y is still less because y is from the top. If I click here in the center, it's almost, you know, the screen is 900 by 600, so here's 450 by 300. So we can get the coordinates of the mouse, and I need to compare the coordinates of the mouse with the rectangle for the button. And this is how I'm gonna check if I clicked somewhere on this button, because this button has a rectangle around it, and if the mouse coordinates when clicked are inside of the rectangle of this button, I know this button has been clicked. So here I write the logic for show instruction panel. And how can I check if the coordinates of the mouse are inside of the rectangle of the button, of the instruction button? And actually Pygame gives us a very convenient function. So this is the button, and we need of course the rectangle of the button, and we have collide point print button clicked. So if I run this one and I start clicking around, nothing happens. I can click this button, I can click, but if I click somewhere in the instruction button, I get button clicked. So anywhere inside of the button I will get button clicked, but outside nothing happens. So if I clicked inside of the instruction button, I want to set the show instructions to true. Now I'm going to click the instruction button and the panel appears. And now I need to add for the close button. So when I click the close button, I want to set self show instructions equals to false. Now, in order to do that, it's not just enough to catch the mouse coordinate, because these mouse coordinates are relative to the screen, and for the panel we have a separate surface. So in order to catch this thing next to the mouse coordinates here, we need to add also the rectangle of the instruction panel. So only if the instructions are shown, so only if this thing is true, only then I wanna, you know, do the logic here. I don't want to be listening all the time here. Just when the panel is shown, then I want to listen for this click event. So mouse x will be equal to mouse x minus the instructions. Yeah, the instructions rect left. So from the mouse coordinate, we need to remove the left position of the panel. Otherwise, it's not going to correspond to the when we click the close button on the instruction panel, because the instruction panel does not have the same coordinates like the screen surface. And we gotta do the same for the Y. And then we need to use the Pythagorean theorem or Pythagorean formula to calculate if we clicked inside of the circle, the closed circle. Now this thing is 880. So when we place the close button, we place it 580 from the left and 20 from the top. So we need to raise it to the power of 2. And then we need to use the square of the sum of these ones. Now, if this thing seems kind of like, what's going on here? I actually didn't came up with this thing. I found it online. Like if you write Pygame, where is it? Check if image is click, if circle. And yeah, here it is. So you need the x coordinate of the mouse, the y coordinate of the mouse. You need to get the square of the x, the square of the y, and you need to pass the coordinates of the shape that you want to click. And I actually asked this question because that wasn't working for me, because I had a shape on another surface, not on the screen surface, but on another surface. And here's the answer that I received, and it's actually working. So actually, let's try it out now. So when I click the instruction button, this thing appears, and when I click the close button, it disappears. So this functionality is working. And if I click anywhere else, it doesn't close. Only if I click the X button. Okay. So we're pretty much done with the UI, with the exception that first of all we need to add these trickster images down here, and we also need to add the free images where we'll be selecting the tricksters. So for these images that we'll be showing, I'll be creating another class called trickster. And because this image will be showing, actually this class will be showing an image, I will inherit, I'll inherit the Pygame sprite.sprite. Okay, we'll have an init function, and the init function will accept three parameters: the file name, and the file name will be one of these, for example 01.png, 07.png, one of these ones. File name. It will also accept an x and a y coordinate, so where we want to place them. And actually when we show the images, we'll show them in the correct order down there. So 1, 2, 3, 4, 5, it really doesn't matter how we show them. It just, I'm gonna make it as simple as possible and just read all these images and then place them in their natural order. So because we are extending the sprite class, because we're inheriting the sprite class, we need to call the super method of the initialize method of the sprite class. Now each tile will have pretty much two states. One state is where we select it, so from the bottom where we select the state, where we select the trickster, and if this image is set, just run it. So the images will be down here, so when I click it and then click the big tile here, I'll set it in the big tile. And when I set it in the big tile, I don't want to set it in other tiles. So if it's selected and then placed on the big tiles, I want it to be also blocked so that I cannot select it again. Because according to the instructions, trick-or-treaters will be different, no two of the same. So I cannot have, for example, two zombies and one witch. They all need to be, like, the free one needs to be unique. I cannot have two of the same. So we'll have an is selected state, which in the beginning all of them will be false, and also is blocked. If it's blocked, it means it has been set and I cannot select it again. And in the beginning they'll all be not selected and not blocked. Now also, just to make things easier, for each image that I create, I will set it, I'll set it an ID, and the ID will be this file name here. So 1, 2, 3, 4, 5, 7, up to 10. So use the file name. So the file name that I'll pass will be 01.png. Now I want to split it by the dot, and I want to take the first part. So this will take the thing before the dot. So 01, 03, and so forth. And of course I want to convert it into an integer, because it will return it as a string. So this will give me 1, 2, 3, up to 10. Now, when I get the image, I'll get it as in its original size, and I'll explain what that means in a second. So the inside of the image folder, inside of the tricksters, is that what we call them? Tricksters. And like always, we use convert alpha just to speed up things, and it's a best practice when you load an image to use convert alpha. Okay, let me explain what is happening in these two lines. So the first one is actually self-explanatory. We're just loading the image. And I call it original image because each image in here is 128 by 128. But when we run the program, there's a closing brace here. So when we run the program, the images down here will be 64 by 64, so I need to scale them. And later when I select the image and I show it in the big tile over here, I don't want if I upscale it, they will look ugly. So that's why I want to preserve the original size of the image and then scale them. And later when I'm showing them on the big tiles, I will use the original image and not, this is the scaled image. This self image refers to the scaled image. The original image is the original one, so I'll show it in the tile, and you'll see it in a couple of minutes. And the next thing also I want to do is I want to draw a rectangle around the image. I'm going to draw a white rectangle around the image. Okay, and then also we need to get a rectangle of the image. It will be the top left, and I'll use the x and y coordinates that are passed to each image. We use these coordinates to position them down at the bottom, horizontally center them down at the bottom. Now, this is the initialize function of the trickster. The trickster will also have a draw function. And the draw function will tell us if the image should be drawn in a specific way depending on its state. Now, as we said, we'll have so to say, three states: if the image is blocked, if the image is selected, or none of the above. So, if is blocked, so if the image is blocked, I will draw a circle on top of it. This is the position of the circle inside of the image, the radius, and this is the how thick the line is. And I'll set select to false. So because if it's blocked, I cannot select it. I shouldn't be able to select it. I mean, I should deselect it, because when the image is selected, you'll have a red border around it, but if the image is blocked, I want to remove that red border. Let's actually write it here. If is selected, red border, red circle. If they're true, true is red border, true is red circle. So if the image is selected, I'll draw a rectangle around it. Now, if none of these are true, I wanna just draw the image. Okay, so now let's just add the update function, and all that the update function will be doing, it will call the draw function. Okay, that's a lot of writing, so let's test it out. So this will be the tricksters. I couldn't come up with a better name, so you can call them costumes or masks or whatever you like. Now I'll need to create 10 tricksters from this class, 10 objects from this class. So because they are inherit from the sprite class, I need to create a group that will hold all these tricksters. And this is usually how we proceed. You cannot show images, sprite images, unless they're in a group. They need to be part of a group. So before actually we create the group, we need to grab all these, the names of all these images. So I'm gonna create a list of all names of these images. And for this one I use this one. And this is actually like a command, that we can use to read all files inside of a folder. And if there are no mistakes, this should print a list of all the file names. And here we have them from 01 PNG to 10 PNG. So now that we have this a list of all the file names, we're going to create a group. And we need to add them to the group. So between each image we need to have a padding of 10. And the margin will be the window width minus the size of the image. Each of them will be 64 pixel height, width. So 64 by 10 will be 640 plus padding times 9, because between the 10 images we'll have 9 paddings in total. And then we'll divide by 2. So this will give me the margin on the left side and margin on the right side. But I don't need a margin on the right side, just the left side, so that I can offset it from the left border. And then we're gonna run a loop. So the x of each image will be the margin plus I times 64 plus And actually this should be padding. So pretty much the x position, x will be, so the first one will be margin plus this will be 0 and this will also be 0, so just the margin. The second one will be the margin plus 64 plus 10, 74, so that there'll be an offset between the images and they'll be evenly spaced out. And the y will be the window height minus 100, so 100 from the bottom. And then we'll create the trickster, which will accept the file name. So we have all the file names here in this list, the tricksters list, x and y. Now all this trickster group right now, all I need to do in order to show them here in the UI is run trickster group draw, and for the draw I need to give it the surface where I want to draw it. Do I want to draw it on the instruction surface or on the screen surface? Of course I want to draw it on the screen surface. And then call the update function. And the update function will take care of like updating stuff on the screen. For I in range, okay, I messed up that name, line 14. It be convert alpha. Let me see. Self tricksters group. Oh, I didn't add him to the tricksters group. Tricksters group at. So we loop over all the file names and then create a trickster from each file name. We set the x and the y coordinate and then we add it to the group. And since we add it to the group, these commands in the draw function will make sure to show the images. And here they are. Now, let me show you actually. Let me explain what's going on here. So here the draw function is for each image, it's going over this code and says, is it blocked? It's not blocked. Is it selected? It's not selected. So it will show the image and it will show a white border around the images. And later we'll let the logic, when we click it, we can select it. And then we click the tile over here, we'll set this image inside of the tile and then we'll block it. So when selected, it will draw a red border around the image. And if it is blocked, it will draw a red circle inside of the image and it will unselect it, so it will remove the red border. Okay, so maybe actually we need to add the tiles here and then we can just add the logic. Now the tile will also show an image. In this case it will not show the image, it will show a surface on which we can place an image. We're gonna write the init function. and this sprites will accept X and Y coordinate. Now the tiles will have just two states. Is it filled or if it's empty? And we'll represent it with a single boolean variable is filled, and in the beginning they will be false. So we're just gonna show the surfaces but without any images, and if there is an image on the surface, it will isFilled will be equal to true. Now this will be 128 by 128, and these dimensions corresponds to the original dimensions of the images. And if you remember here when we said that the trickster images, we grabbed the original image and then we scaled them to 64 by 64. But we'll be using the original image when we set the tiles with these images. So the image for the tile will not be an image from it will be a surface. Now we'll fill all the images with white. And we'll take the top left, which will be equal to X and Y, which will be passed to each image. Okay. So just like the tricksters, we need to create the... We have only 3 tiles, and we need to have a group for those tiles. So for the padding, it will be 20, and let's quote the tile margin. We'll use the same formula. Now they are 128 times 3, and tile padding will be times 2, because between the 3 images there will be 2 paddings divided by 2. And for the Y, we have the window height minus, so 300 from the bottom. And last we need to add it to the group. And just like the trickster group, we're gonna add the tiles group. We're gonna draw it on the screen and call the update also function. So if I run this thing, you'll see the 3 tiles appear here. Now these tiles appear white, and I don't want them to be white, I want them to be like sort of transparent. So I want to be them like like see through. I want to see the background be underneath those tiles. So here in the tile, when I create the surface, I can actually pass additional parameters to make sure that they're transparent. And besides the width and the height, I need to pass other two parameters. One of them is source alpha and 32. And let me just call also convert alpha. Now if I run it, they won't show transparent, because here when we fill it, we fill them with white. But I don't want to fill them with white, because white is defined as 255, 255, 255. Now you can also add a fourth parameter which sets the transparency. And again, this parameter can be between 0 and 255. So if I add, for example, 10 and run it, line 39. Oh, sorry, this needs to be a tuple. So this fourth parameter will make sure how transparent it is. And right now they're transparent, but they're so transparent they're almost like invisible. So if I make it, for example, 210, you will see they are more white than transparent, but you can still see underneath. And I want to make them 120. And there, I like this one. I like this effect. So they are semi-transparent. You can see in the, underneath what's going on here. Okay, now currently nothing has happened, but before we add the logic for these images and these tiles, I'm gonna add to the tile class two more methods. The one of them is set image, and the set image will set an image for the tile, because in the beginning the tile will be just plain surfaces, and when I select an image and place it on the tile, I want the image to show, the tile to show the image. So of course, self-filled, I'll set it to true, which will tell the game that there is something inside of this tile. This tile is set. There is an image in the tile. And then this image that is filled with this transparency, I'll set it equal. I'll set it equal to the image that I pass. Now, this image that I pass will be a instance of the trickster. And wait. Okay, this will be an image of the trickster. And then I will transform it to 128. So setting the image, we'll set this transparency with the image, and then also need to have another function onset image. So when I unset the image, I want to remove the image and make sure that this semi-transparent surface is shown. And I'm actually going to copy these two lines here, because this is what we're doing here. Okay, so when I run, nothing is bugging out, everything is good. Now I believe what we need to do right now is add the logic for our game. I mean, when we're selecting the images, actually let's start with that. So in the user input, here we're checking for the events, but actually before we check for the events, I'm gonna grab all images inside of the trickster group. So with this command, because this self-trickster group is a group, using .sprites, I'm gonna get all objects that are inside of this group. And I need that because I don't want to be using this thing over and over again. So I will get all tricksters inside of this variable. And here, when we are checking, so select tricksters. So I want to iterate over all the tricksters. And I want to check if I have clicked a trickster. If trickster is selected, so I want to make it, if a trickster is selected and I click it, I want to unselect it. Rather than false. So this should make sure that when I click a trickster, I will select it. Okay, that is not supposed to happen. For trickster and trickster. Okay, only when the trickster is... Okay, sorry about that. So if the trickster, if the rectangle of the trickster collide point with the mouse coordinates, so I'm iterating over all the tricksters in the trickster group, and if the current trickster, if the mouse coordinates collide with are inside of the current trickster rectangle, I want to select it or deselect it. So if I click it, I'll select it. If I click it again, I'll unselect it. So I can select many tricksters and I can unselect them. Okay, that's good. What else we want to do? We actually need to have a variable that will keep track of the current selected trickster. So here in the tricksters, I'll have selected trickster, and by default it will be none. When you start the game, this selected trickster will be none. So we'll be using the selected trickster to find out which tile we need to set. The selected trickster will tell us which image we need to use to set on the tile that we have selected. So it's not select tiles, it's more like okay, let's call it select tiles. Now we're going to iterate over all the tiles in the tiles group, and we need the index variable also. Now, if I click on a tile, I need to check if there is a selected trickster. And if there is a selected trickster, I need to set the tile to this selected trickster. So if there is a selected trickster, I'll get the original image from the trickster, because the original image will be in its original dimension. It won't be scaled. And then the selected trickster, the current index of the selected trickster will be equal to selected trickster ID, and I want the int of this one. So selected trickster. I'm sorry, the selected tricksters. If the selected tricksters, did I create that variable? Okay, so for the tiles I need to create a selected tricksters variable and I'll set it equals to 0, 0 and 0. So in this list I will keep the numbers, for example 1, 2 or 6, and these tiles will show these numbers, and if these numbers are 0, this means the corresponding tile is not set. I hope this makes sense, because it's getting kinda, it's not complex, it just needs a little bit thinking. But pretty much, if I have selected a trickster, let me run this thing. So if I selected one of these, this is 1, 2, 3, 4. Number 4 will be selected, the selected trickster. And if I click a tile, it will set this image in here. And this will not be 0, this will be 4. So the selected tricksters will be 4, 0, 0. If I select this one and set it to the second one, this will be 4, 10, 0. And if I select the first one and set it here, it will be 4, 10, 1. So this is the purpose of the selected trickster. So I will take the ID of the selected tricksters and I'll set it to the selected trickster ID, because each trickster will have an ID that corresponds to the file name, and this is how I can know that they're unique. So once I do that, I'm going to iterate over all the tricksters. And if the trickster ID is equal to the selected trickster ID, I need to block it. If the selected trickster from the bottom is set to the tile, I need to block it. And I don't think this will work right now, because we didn't write the other logic. If self-selected, and the reason why it's not working is because here, when we're going over all the tricksters, so if the trickster is selected, I need to set the selected trickster to the trickster. So when I select the trickster from the bottom, I will set the selected trickster to the current trickster. If trickster is selected, I want to deselect it. Actually, this will be none. So a trickster is selected and I click it again, I want to deselect it, and therefore I want to make selected trickster equals to none. But if the trickster is not selected and I select it, I will set selected trickster equals to trickster. And let me run this game. So I can select and unselect. And actually it shouldn't be selecting the other tricksters. I should select only one trickster at a time. So here it's blocking it, but it also I also shouldn't be using the block trickster to set it to another tile, because the tiles need to be unique. So here, when we're checking the user input, just correctly stated. So I will iterate over all the trickster. And if the trickster ID so if the ID of the trickster is inside of the selected tricksters, so the selected tricksters will be one of 3, because they are 3 tiles. Trickster is blocked will be equals to true. Else trickster is blocked will be equals to false. So here in the user input, I'll make sure that if a trickster okay, this is getting kind of long, I know guys, but it's just the way it is. So if an ID of a trickster is in here, in one of these, I'm gonna block it, because if it's on the tile, it should be blocked and I shouldn't be able to use it. So okay, I cannot, let me try to use it again. Okay, that's not supposed to happen. But it's good, because you see, when I select one, like you see, when I select the tricksters, they correctly show in here. So that's good. I shouldn't be able to select different ones. Okay, so here in this function, in this condition, when we're clicking the tiles, if there is a selected trickster, we're gonna set the tile to the selected trickster. And then, oh, we didn't preset the selected trickster equals to none. Okay, so that should be working now. Okay, I cannot use this one to set it on others, because the selected trickster is set to none. What the? Okay, we can still click these ones down there. So if selected trickster elif tile is filled. So if a tile is filled, I shouldn't be able to click on it. I mean, I shouldn't be able to set it again, because it's filled. So I need to go over all the tricksters Now if the trickster ID is equal to the selected tricksters do I have the index? Just check. Okay, because we're in the loop here. Okay. If the current ID of the trickster is set to the index of one of the selected tricksters, I need to block the trickster. I mean unblock it. Because if a tile is filled and I click it, I want to remove this tile. I mean remove the image from this tile. I'll unset the image, and then for the selected trickster's index I'll set it equal to 0. Okay, let me try this one now. So I can unset the images, but I can still select more than one images. So let me see what's going on here. So and not trickster is blocked. So I want to select and select only if the trickster is not blocked. Let me try this one now. Okay. That seems to do the trick. So I cannot select a blocked image and set it again. I can unselect tiles and they are unblocked, but once I select a tile, the image down there is blocked, and if I click it and I try to set it on unsetted tiles, I cannot do it. Good, so this thing is finally working. So when we select the tricksters, we need to make sure that the trickster is not blocked. Not just we click the trickster, but also only if it's not blocked, then we want to select it or unselect it. And I hope this thing kind of makes sense. It's not that hard. Again, it just, you need to think a little bit about it. Okay, so now we want to create the sequence of tricksters that we want to guess, because currently we're just like, we don't know which is the order of the tricksters that we need to guess. We don't have that logic written yet. So I'm gonna create a list of the images we need to guess, and I'll call it guests. And of course I need to create this function. So get guests will generate 3 random numbers, and then this self guests will compare it with the selected tricksters, and if they coincide, the 3 values here coincide with the self guests, that means we won the game. Now in order to generate the guests, I'll create an options of a range from 1 to 11. So this will generate numbers between 1 and 10. And if we have the images are between 1 and 10, including. And of course this needs to be a list. And I can actually just print these options and see if everything is working fine. Okay, that should be empty. Get guests accepts no parameters. And we generate a list between 1 and 10, just like the images that we have. So from these images, I need to randomly select 3 from these options. And I will actually return them. And we'll use the random function and to randomly generate a specific number of elements, unique numbers. We use the sample function and we pass how many, in this case 3. So this will return, it will randomly select 3 options, 3 choices from this list, and they're not going to be they won't be repeating. So it's not going to select, for example, 2 4s or 3 7s. All of them will be unique from this range. And if I print them, and run this, so it gives me 4, 7, and 6. So in order to guess, in order to win, I need to select 4, 7, and 6. And this is the winning combination. We just don't have the logic for it, so it doesn't show anything. Okay. So once this is done, now we need to actually add logic for this button, for the guest button. So in the user event function, when we're checking, so here we show the panel, hide the panel, and here we can say check guess button. Let's just see if this thing is working. So if I click the guess button, I get check. If I click other places, nothing happens. Okay, so in this function, we'll actually call a function called self check guess, and this function check guess will return a string. So it will return like a clue, for example Pico, Fermi, Bagels, or something else, for example when we win, and I'll catch it in guess message. So I need to create this variable self guess message. And this will be equal to nothing. So when we start the game, nothing will be here. And we'll actually be printing this message. We'll be blitzing it in the draw function. But I also need to create this function, check guess. Now in the check guess function, I wanna make a couple of conditions. First of all, I will extract all the selected tricksters. I also create a queues array, which will be empty in the beginning, and then I need to make sure that when I click the button, so if I click this button and nothing is selected, I want to show a message because I want to, show some sort of a user, not input, but that they need to fill the tiles. So zero. So if these are filled, I'm going to do something else. Select free tricksters. Now let me see, where should I put this thing? So I'm gonna create a guest message. And I'll be using this guest message that I'll be receiving from this function. Place it 10 pixels from the bottom, and all I'm gonna do is here blitz the screen. Now in the beginning, when I run the the game, nothing is printed there because it's equal to an empty string. But if I click the guess, it tells me select free tricksters. So I need to select free tricksters, or if I select one, it will still show it. And if they fill, nothing happens because I didn't write the logic for these ones. And let me actually put it maybe 20 pixels from the bottom. Okay, that's better. Okay, so if nothing is selected, I'm gonna, if the free are not filled, I will print out select free tricksters. And then here I need to write the rest of the logic. So I'm gonna check if we win. And I'll do it in the kind of not the most optimized way, but now the guests is what we generated. This is the numbers that are generated. And so if these conditions are true, I'll set winner to true, and I'll return an empty string. Now, if we don't have a winner, I'll set tries left, I'll decrement them by 1. And then I need to iterate over the tricksters and see what clues I can give to the player. Now there are 3 options. Now if the selected trickster is equal to the guest, so that means that I have a right digit in the right position. This is Fermi. This is what we want. Now, if the selected trickster is not in the right place, but is somewhere else in the list, we'll have Pico. Now, if they're queues, I mean, if there are no queues, what was that? Oh, we're just gonna return Bagels. Else, if there's something in the queues array, either Pico or Fermi or Pico or something like that, before I return them, I'll sort them because I don't want to give away the order. We'll sort them and then we'll return them. it out now. So hopefully I'll guess something. Clues. 31. And that's cues. I don't know why. Or maybe they should be called clues. So let's try it out. And I have Pico, so means one of these is in the correct position and in the correct order. Okay, so I have Fermi when I change it to a witch, so this witch is either here or here. Okay, so I'm pretty sure these two are in the correct position. Oh, wait a minute, Pico is in the wrong position. So let's put it here. Pico, Pico. So these two are correct. Fermi, Fermi. So the last one is one of these. And this is the correct combination. Nothing happens because we won. But we didn't write the winning logic as of yet. So here in the user input, when we're checking for the mouse button down, we actually need to add another event type when we press the space key, and we'll be adding the logic in a while. But let me just first add it in here. So if the event type is a key down and the event key is Pygame key space, we want to start the game again. So tries left will be equal to 10. We need to generate a new set of guests. The selected trickster will be again equal to none. Selected tricksters will be equal to 0, 0, 0. Winner will be equal to false. And the guest message will be equal to an empty string. And then we need to reset the tiles. We are just unsetting the image. And here for the event type, when we're checking for the mouse button, I want to do that not only when I click the mouse, but also the tries left is different than 0, because if I run out of tries, I lose the game and I shouldn't be able to click on the screen. I should only be able to press the space to start the game. And we actually forgot to print the tiles, I mean the tries, how many tries we have left. So here when we're printing the lines, tries left, center. And the actual tries. So let me just think, where should we put them? Doesn't matter actually. Well, actually they need to be before the instructions. Otherwise, when you show the instructions, they will show on top of them. So in here. Okay, here we get the tries left, and when I click them, they start to decrement. And we need to handle the winning and the losing the game. So here when we're calling this, actually, why did I left it orange? I'll just make it black. So if I run out of tries, it means I lost. Try again. Try again next Halloween, if you dare. And play again. we'll show the tombstone image. This should be screen.blit. Haha, you died. Right. Try again, rect. Play again. So this is for the losing. If we win the game, and you know guys, I'm just gonna copy and paste this thing here. I know this is a bad practice, but I just want to speed things up. We can actually write in a single one, but we don't have time for this. Press space to play again. Instead of the tombstone, we'll show the ghost image, the happy ghost image. Else, now all of this, I'll just move it in here. Okay, let's try to lose the game. Test 27 text font. I guess I messed it in here too. Okay. Bagels. So last one. You died, try again next Halloween, press space to play again. I press space and I get, and let me just win, and in order to win I'm gonna print the guests. So the guests are 10, 3 and 2. So this is 10, 3 and 2. Yes? You won, congratulations. Press space to play again. And congratulations should be in black. And we start again. And everything is working as expected. So let me just make this thing black. Congratulations will be black. And that's pretty much the game, guys. I know there was a lot of writing here for these instructions and stuff like that, but I think it's a pretty nice game. And like I showed you, this is just a number guessing game, but we put a Halloween spin on it, and instead of digits we use images. So I hope you have fun playing with this game, and if you wanted to make it even harder, you can add like 4 or 5 tiles, but it gets like insanely hard, like really hard to guess. But that's it from me, and I'll see you guys in the next video.